alaikum. We are back in part 3, and in this part we are going to talk about selection. So the Boolean data type and its operators, we know that a Boolean data type gives a result of either true or false. So if we have a Boolean and in Java, a Boolean data type is written as Boolean, the full word, and we define a variable name, and we call it, for example, b is equal to, if we say the statement 1 is greater than 2, the answer will either be true or false. In this case, it is false. So this b of data type Boolean is equal to false. And we have 6 relational operators, which is less than or equal, greater than or equal to, and not equal. And it is very similar to the way we use them in C++. So the way that we write an if statement, a one-way if statement, is that we write if and then the condition, and between curly braces we write all of our statement. This is almost exactly like C++. So for example, if we have a test and test is equal to 5, if test is less than 10, and then whatever we want to do if the value of test is less than 10, it will be executed here. And then the rest of the code will be executed here. And then this just shows if the expression was false. If it wasn't, then whatever's inside the if statement will not be executed, and control will move to after the last line of the curly braces belonging to the if statement. So here we have an activity. Write a program that prompts the user to enter an integer. If the number is a multiple of 5, print high 5. If the number is divisible by 2, print high even. I encourage you to do it in NetBeans and see your answer. A two-way if statement is when we write if, a condition, and then the statements after it, else, and then a number of statements. The way that we write this is that we will write int, and then, for example, if we have a variable called test, it is equal to 5, for example, if this is our if statement, and then test is less than 10, and then we close the parenthesis, and then if this statement executes to true, whatever's inside the if will be executed. If it evaluates to false, then whatever's inside the else will be executed. So here we have an example of how we can write it in Java. So if the score is greater than or equal to 90, system.out.print a, else, and then we can write another if statement. If it's greater than 80, then system.out.print b, else, if the score, and so on and so forth. And this statement is also equivalent to writing if the score is greater than or equal to 90, the system.out.print a, else if score is greater than 80. So this is easier on the eye, easier to be read. So this way is better, but to the compiler, to your computer, these two are the same. So here it shows you how the chart flow is written. Both of them are equivalent. We reach the same goal. Here I encourage you to do this activity to see how the flowchart for this pseudocode will be written, especially if you haven't had a computing class before this one. If you've already studied C++, I'm sure you know the answer to this. If you haven't, then try it out, and if you want to ask me about it and check the results, you can always send me an email. Now, what if we have two if statements followed by an else? The way that we write this code is, for example, here if we have int I is equal to 1, j is equal to 2, and k is equal to 3. And then if we have if I is greater than j, which in this case it evaluates to, I is 1 and j is 2, it evaluates to false. So does this else belong to this if, or does it belong to this if? Well, this language is not Python, so the indentation doesn't matter here. What matters is that the else belongs to the most recent if. If this was Python, then the else will belong to this if. But because in Java and C++, indentation is not important. What is important is the sequence of statements. So this if belongs to this else. If I wanted this else to belong to this if, then I have to write a curly braces here to say that this is my if statement and this is the else for that if statement. Otherwise, if I don't write it, it will be understood that this else belongs to this if. But this writing is confusing, so even though the compiler doesn't care about the way that you write it, it is better for the eyes for another person who is reading your code to be written this way, with the correct indentation. So in this example, 1 is greater than 2, which is evaluates to false. It will skip both of these statements, and then if we have other statements after this block, it will be executed. So here we have a fifth activity. What will be the output of the following code segment? We have int I is equal to 1, j is equal to 2, and k is equal to 3. If I is greater than j, I is 1, j is 2, and then if 1 and 2, which evaluates to false, and then we have, because it's false, this means that we will not even enter this part, we will go to the else. So this example just shows you that if we add the curly braces, this else will belong to this if. If we don't, then if we don't add this curly braces, the else will belong to the if, the closest if. So you can try it out and record your answer. You can use NetBeans to double check. It will give you the same result. So here we have another activity, activity 6. It tells you what would be the output of the following segment. Try to pause the video and record your answer. Okay, so if you try it out, it should give you which type of error. Well, it's not a syntax error, and it's not a runtime error. You can check this, double check this using NetBeans, but it's a logical error. Why is it a logical error? Because, I'll give you a hint, we have something wrong with this statement in our if conditional. Let's run it on NetBeans. So if we run it on NetBeans and we have okay. So what it says here is that if the radius is greater than or equal to 0, this should be executed. So let's try to give it -5, which means this shouldn't be executed. What do we see here? It has been executed. Why? Because we added a semicolon. What does that mean? How does adding a semicolon make a difference? Well, because adding a semicolon means that the if statement as a whole has ended, and we're moving on to a new block. So this will be executed regardless of this conditional, whether it's true or false, because we ended the conditional statement. If I wanted it to be only when the radius is greater than or equal to 0, then we have to remove the semicolon. That is a common mistake. So now, I forgot to tell you about it. Now it doesn't give us any answer. So because it's less than 0, but if we add a positive integer, it will give us the result from the conditional. So the logical operators are used to combine many Boolean expressions. So for example, the not operator, if I add a not before a variable, for example not x, and the variable x stores true, then this will be false. Let's just make it more clear. And if it was false, then not x will be true. The AND operator, it has its own truth table where truth and true, if we have a true and another true, it will result in a true. This is the truth table. And true and false is false. False and true is false. And false and false is false. The OR is the opposite. True and true is true. True or false is true. False or true is true. And false is false. XOR is if we have different values, we will get 1. If we have opposite value, if we have the same values, we end with 0. So true and true, or false and false, we will get 0. If we have true XOR false, false XOR true, we will get 1. So if we have a variable x XOR a variable y, if they are different, we will get 1, which is true, which evaluates as true. If they are the same, false and false, it will evaluate into false. Which I'm sure most of you know this because you've already had a previous programming course, but if you haven't, this is a small summary about it. Now we move on to the switch statements. The switch statement, it is a conditional statement. It is an alternative of writing if else, if else, if else. So instead of writing if else this way or this way, we can also write it in a switch statement. But not all statements that we can express using if else, we can express it in switch. But what can we express in a switch statement are some of the conditional statements. So it provides another way to decide how statements are executed. The switch statements evaluates an expression, then attempts to match the result to one of the several possibilities. The match must be exact match. It makes it easier to look at. So that is why sometimes it's preferred to use a switch as opposed to an if else. But what are the rules? When can I use a switch? The switch can be used when we have a value. This value can be either an integer, a char, or which is short for character, a byte or a short. But if we have, for example, a different type of if condition, if we had a if condition that involved different variables together, then we cannot use a switch. So here we have an example that we use a switch. We have int, which is an integer, roll, a variable, which is equal to 3. And then we have a switch statement. We write here the name of the variable, and then we have different cases. Each case is either a number, or a character, or a byte or a short. They have to all be of the same type. So here, for example, we have roll is 3. So in the switch statement, the roll is 3, then we'll move to case 3, and it will execute whatever is in case 3. So we have here a break statement. What this does is it breaks us from the switch statement to the end of the switch, moving on to the rest of the code. If we do not have a break statement, which is optional, then it will continue to the next case if we have more cases, and it will continue to the default until it reaches a break or the end of the switch statement. Also, having a default case is not necessary, it is optional. But if we have a default case, it allows us to give a result to a value that is not found in the cases. So for example, if we have here, instead of 3, we have 7. So it will go to the default and it will say no student. So here we have an example. I encourage you to pause the video and try to find this results. So here we have an integer, which is day 5, and then we have the switch statement with the day variable, which should be an integer. So the cases should be an integer. So we have case 1, 2, 3, 4, up to 7, and then we have a default value if we have a day that is not from 1 to 7. And we also have a break after each case, which means that it will execute the case and then leave the switch statement. So here the day is 5. Switch we have the day of 5, and then we will move to case 5, and then the day string variable will store Friday and then break, so that means we will leave the switch statement. Now if we print the variable day string, it will print Friday for 5. What about for 3? It will print Wednesday. For 7, it will print Sunday. For -1, this is not one of the numbers, so it will print invalid day. For 8, it will print also invalid day. Now here it is different. If we can see here that case 1, 2, 3, 4, and 5, they all share the same result, which is day type is equal to weekday, break, and then case 6 and 7. So if the day variable gives us 6 or 7, this will be the result to be executed. So day type will be equal to weekend, and then we can break from this switch statement. So for example, for 5, it will be case 5. The day type is weekday, so what will be printed is day 5 is a weekday. For 3, it will also print day 3 is a weekday. For 7, it will print case 7, which is day type will be weekend. So day 7 is a weekend. -1, it will print the default invalid day type. So day -1 is an invalid day type. And the same will go for 8. So conditional operator is a ternary operator, which means that it has 3 parts. First, you will type the Boolean expression, and then the question mark, and then what happens if the Boolean expression results to true, what do you want it to be executed, and then a colon, and then what happens if the Boolean expression results to false, and then a semicolon. So for example here, if A is less than B, this is the Boolean expression. If it results to true, then 50, which is the variable stored in X, the value stored in X, and if it was false, it will be 60. So this expression has 3 parts. This part, which is the Boolean expression, this is what happens if the result of the Boolean expression is true, and here is the result if the Boolean expression is false. So here it shows you the syntax. So I encourage you to try to solve this activity. If num mod 2 is equal 0, then system.out.println num is even. So if num is 11 mod 2, it will equal 0. This will return to false. So it will go to the else, and it will print 11 is odd. Then system.out.println num mod 2 is equal 0. This is the alternative way of writing it. Num is even, and then num is odd. So instead of writing it this way, this is an alternative, and it will give you the same answer. So the operator precedence, as we've seen in other programming languages, that is the same. The highest precedence is for the post increment, and then the pre-increment and the unary operator plus or minus, which is the negative or positive of a number, and then casting, if we cast, this has higher precedence, and then the not operator, and then the multiplication, division, and remainder, and then the addition and subtraction, relational operators, equality, XOR, conditional and then conditional or, and then the assignments. Okay, so here we have an example of how associativity works. So we know that most operators are left to right associativity. So for example, when you have let's say 3 times 2 divided I'm writing it in math terms. It's clear. You can then convert it to computer science terms. But anyway, so when we say that it has left to right associativity, it means that we start this way from left to right if they have the same precedence. So for example here, we multiply and then we divide instead of dividing and then multiplying. This is the order when they have the same precedence. So this is what we mean by operator associativity. There are some operators that are from right to left. A good example is the assignment operator. So for example, if I have x is equal to 3 times 2 plus 5, I always execute whatever is on this side, which is the right side, before I execute to the left side. So what that means is I have to execute whatever is in here, and then I assign it to the variable x. So here we're going from right to left instead of, as we've seen here, from left to right. So we have to be careful with that. And here we have an example. So if we have this expression, what we will look into first is what is the highest precedence. So we can see that multiplication, division, and modulus all have the same precedence. So we start from left to right. So we multiply the 10 by 50 and then add, and then we divide the 100 by 10, and then we add the subtraction by 5 plus 7 mod 2, and then in another statement we will compute 7 mod 2. So as we can see here, we go from left to right to those who have the same precedence. We start from the highest precedence in the expression, and then from left to right we execute those of the same precedence. And then, since the rest of this statement have the same precedence, which is addition and subtraction, they both have the same precedence, we also go from left to right. So we add and then subtract and then we add. So we add here and then we subtract the value added, and then we add the last value, and then we get the result. And of course, if we have parentheses, then that gives any operation the higher precedence. So if we have, for example, parentheses here, then this will give addition the higher precedence, even though usually multiplication have higher precedence than addition, because we added the parentheses. So here, as we can see, we start with this expression, 4 plus 3, and then we go from, after we complete this, we go from left to right, starting with the highest precedence. So here we have two values with the same precedence, but we start from left to right. And so on and so forth until we get the final answer. Okay, so in another video we will continue with part 4.